Hey, what's up guys? In this video we're going to use the elimination method to solve some systems of equations that are a little bit more challenging. Alright, here it is. Hey guys, last video we introduced the concept of elimination and how we can use it to solve systems of linear equations. And in this video, we're just going to sort of take it a step further and tackle some more difficult ones. So if you remember how elimination works, the goal was to either add or subtract your equations together with the hopes of getting one of your variables to eliminate. So the problem with an example like this one, for example, is let's say we were to add these equations together. Well, then I'd have 14x plus 7x, which is 21x, so the x's don't eliminate. And negative 4y plus a positive 8y is a positive 4y, so they don't eliminate that way. And then, so addition doesn't work. But then as you can see, subtraction's not going to cut it either, because 14x minus 7x is 7x, and negative 4y minus a positive 8y is negative 12y. So in both cases here, we don't eliminate anything. And so we have to get a little bit creative. So remember, you're allowed to do anything to an equation as long as you do it to both sides. So let's say if I wanted to add or subtract these and get them to equal 0, well then I would want this 7 to be a 14, because then I can subtract the equations and I'd have 14x minus 14x, which is 0. So to make this 7x a 14x, I'd have to multiply it by 2. But remember, you can't just pick and choose parts of the equations to multiply by 2. So what we're going to do is we're going to multiply the entire equation by 2. Because again, whatever we do, we could do anything we want to the left side as long as we do it to the right side. So now I'm going to recopy this top equation since I didn't do anything to it. And now I'll multiply this entire equation by 2. So you could sort of think of this as the distributive property. 2 times 7x gives me the 14x that I wanted. 2 times positive 8y is a positive 16y. And then negative 10 times 2 is negative 20. And now these coefficients match. The 14 matches the 14 up here. So now I can go ahead and subtract these equations to get my x's to eliminate. So 14x minus 14x, which is 0. That was by design. And then negative 4y minus positive 16y is going to be negative 20y. And then 40 minus negative 20 is the same thing as saying 40 plus 20, that's going to be 60. And so now we can divide both sides by negative 20. And we see that y is going to equal negative 3. And then to figure out what x is going to be, I can go ahead and plug this negative 3 into either of these equations here. I'll plug it into this original one. So I have 7x plus 8 times negative 3 equals negative 10. And now I can just do the math here and solve for x. Alright, so simplified this 8 times negative 3 to negative 24. Then I added 24 to both sides. And then I divided both sides by 7 and got x equals 2. And remember, the solution to the system is an ordered pair where x always goes first. 2 comma negative 3, x comma y. And that is the solution to the system. All right, so this one here involves a fraction, which is totally fine. And again, you always want to check to see if adding your equations together or subtracting them will get anything to eliminate. And in this case, it won't. So both addition and subtraction doesn't work as is. But again, we can multiply one of our equations by something to get our coefficients to match here. So here I have an x, a 1x, and here I have a half of x, 1/2 x. So I want my 1/2 to be a 1 so that they would match. So again, I'm going to end up multiplying this equation by 2. And the reason I'm going to do that is so that because 2 times a half is 1, so the 1 will match the 1 that is up here. So I'm going to recopy my top equation. And now multiply this bottom equation by 2. And so 2 times a half of x is just x. 2 times negative y is negative 2y. 2 times 12 is 24. And again, I'm going to subtract these equations because x plus x would give me 2x. I want them to eliminate, so I'm going to have to do x minus x. And then 3y minus a negative 2y. That's the same thing as saying 3y plus 2y. So that's going to be a positive 5y. And then negative 6 minus 24 is negative 30. And then I can divide both sides by 5. And we see that y is negative 6. And then I'll go ahead and substitute my negative 6 into y over here. So I have x plus 3 times negative 6 equals negative 6. And then we can simplify this down. Add 18 to both sides. All right, so the solution to this system would be 12 comma negative 6. All right, we'll do one more. For this one, sort of right off the bat, we see that we could get the 3 to become a 15 by multiplying this bottom equation by 5. And you can absolutely do that, but just to sort of highlight the fact that there's multiple ways to do these, I'm going to go ahead and get the y's to eliminate instead. So, but again, if you want to go ahead and multiply this bottom equation by 5, then you absolutely can subtract the equations. But again, I'm just going to try something a little different here. So let's say I wanted to get these y's to eliminate. So one thing we could do is we could get the 2 to become a 4 by multiplying this bottom equation by 2. And then I can subtract the equations. But since I have a lot of negative signs here, sometimes it gets confusing to have to subtract a negative over and over again. So instead of multiplying this bottom equation by positive 2, I'm going to multiply this bottom equation by negative 2 so that I can get some of these signs to flip. So I'm going to copy my top equation again because that's I haven't changed that at all. All right, and now I'm going to multiply my bottom equation by negative 2. So negative 2 times 3x is negative 6x. Negative 2 times negative 2y is a positive 4y. And then negative 2 times negative 16 is positive 32. So now, instead of having to subtract a bunch of negatives, I'm going to go ahead and add these equations together. All right. And so 15x plus negative 6x is positive 9x. And then negative 4y plus positive 4y is 0, which is what we wanted. And then negative 50 plus 32 is going to be negative 18. And then we can go ahead and divide both sides by 9. And we see that x is going to be negative 2. And then I will substitute this negative 2 in for this x here. So I'll recopy that equation down. 3 times negative 2 minus 2y equals negative 16. And then we can simplify this down. Alright, then we can add the 6 to both sides. So we get negative 2y equaling negative 10. And then we can divide both sides by negative 2. And we see that y is going to equal positive 5. And so the solution to the system is negative 2, comma 5. Alright, and with that said, it's been demonstrated.